In the last section of this lesson 4.2, we're going to be finding the areas of sectors. They've got a little interesting tidbit on sectors here. First, to start us off with, recall that a sector it's a part of a circle that's bounded by the central angle and its intercepted arc. So this is a sector. It's a portion of the circle that is cut off by the initial side and the terminal side of an angle. And then we have an angle theta here, which can be measured. It can be measured in degrees or radians, but we're going to try to get it into radians as you see as we go through our key concept here of a sector formula. So first of all, that's what a sector is. It's a portion or a piece of the circle that's cut off by its intercepted arc and the initial and terminal sides of the angle. Then what we want to do is we want to be able to find the area of this intercepted arc. Now what they want us to do is use a formula here that we can use, and there's other ways of finding it, but I'll just stick to what they're showing us here. And they say that the ratio of the area of the sector to the area of the whole circle. So we're looking at the area of the sector compared to the area of the entire circle is equivalent to the arc length of the sector and the circumference of the whole circle. So they're looking at the ratios of area of the sector to area of the whole circle is equal to the circumference of the portion of a circle to the circumference of the entire circle. So they're comparing parts to whole every time. So the area of a circle can be calculated by finding pi r squared. So the area of the whole circle is equal to pi r squared. The circumference of the entire circle is 2 pi r. So what we're going to do is we're going to compare the ratio of these two missing pieces. So if A represents the area of the sector, which means a portion of it, the portion is to the whole, as the length of QRS is to the whole. Well, we can find the arc length of the entire thing. Arc length is r times theta. If you remember that this arc length S was equal to theta times r. So that's r times theta is to the entire arc length. So they're going to get rid of dividing by pi r squared, and they multiply by pi r squared. So when they do that, they have A equals r times theta all over 2 pi r. Then they take it times pi r squared, which is going to go over 1. The pi's will reduce. The r squared will reduce with one of the r's, and then we'll be left with r times theta times another r, which is r squared, divided by 2. So there's their formula, and if they don't like divided by 2, they pull the half out there, r squared times theta. So what we'd have is a formula for the area of a sector. So I would kind of like to go area of the sector, but whatever they have, this is their formula that we're going to use and apply. There's some things that we got to pay notice to here. First of all, make sure that theta is an angle measured in radians. This is only a formula that is good if theta is in radians. So in the next two examples, we're going to apply our formula that says the area of a sector is equal to 1/2 the radius squared times the angle, central angle in radians. So applying that, we're going to use our information. We got 1/2 times the length of the radius is 1.5. We got to square that. We got to take it times the central angle in radians, which in this first example they gave it to us in radians, and it is 3 pi fourths of a radian. So we just have our calculations left to do, and we'll go and grab our calculator to help us with those calculations. Clear those off. We have 1/2. We're going to take it times 1.5 squared. The order of operations will take care of that. It'll do the squaring first, and then multiply by 1/2. We got to take that times, and I'm going to put the 3 pi fourths in parentheses just so I can see it as a separate entity here. 3 pi divided by 4. And that should be the area of our sector, which should be 2.65 square feet. Area of a sector. Pretty straightforward, easy to do. They provide you with a formula. They ask you to plug it in and go ahead and crank out the numbers. Okay, the second one, just a little extra step in here because theta is an angle. It's measured in degrees. So first thing we want to do is we want to take theta, which is measured in degrees, and we want to convert it into radians. So we'll use our unit converter, which says if we have 180 degrees, it's equal to pi radians. So that means we can get rid of our degrees, and we'll have 50 pi over 180, reducing, we'll have 5 pi 18ths for theta. Now we'll go and we'll get our area of a sector is equal to 1/2 the radius, which in this case there is 6 squared, times our central angle in radians, which is 5 pi 18ths. In this one, we could go ahead and crank it out just on our calculator, but I'm going to do a couple of things here first. That's 1/2 times 6 over 1 times 6 over 1 times 5 pi 18ths, just to give a little bit of a demonstration. The 6 will go into 6 once, so then we went 18 3 times. And we could take half of 6 and make it a 3. So all we're left with is a 3 on the bottom. And on the top we have, oh, why would I even do that? I can get rid of this 3 with this 3. So all we have left is 5 pi. So whatever 5 pi is, that'll be our solution. And again, you wouldn't necessarily have to do that, but if you do, it makes this calculation a lot easier. Come on. Let's see why I want to clear that out. 5 second pi, enter. Should be about 15.7 square meters. So equals about 1 square meters. So area of the sectors, that was the final portion of our investigation or our lesson today.